So how do I calculate the plasticity index, the PI? Easy. I just do the PI is equal to the liquid limit minus the plastic limit. Okay, just like I showed you in your course notes. So if I do 54 minus 28, I actually get 26. Okay, so just to summarize, the liquid limit, let's say 54%, the plastic limit, say 28%, because it's the average of all of these guys, and PI is equal to 26, the difference. Okay, so what do I do with all this information? I go to my trusty textbook. And once we get to the textbook, we're actually going to use the figures that you were introduced to when you did your first lab. Okay, they're the figures that looked like this, the tables that look like this on page 21, 22, and then this figure here, figure 4, on page 23. So if you flip first to this page here, it starts on this side here, fine-grained soil, which is what we're looking at, right? It's the stuff that passed the 200 sieve. Then you move on to the next table, and it says for silts and clays having a liquid limit less than 50. Well, our liquid limit definitely higher than 50 for this example. So we don't use any of these, right? This is higher, less than 50. Ditto, less than 50, less than 50. None of these apply. I then move on to the next page. Silts and clays with a liquid limit greater than 50. Yes. Well, then it's making references to a line A. And that line A, okay, so here's what you are going to come out with, but the line A here is what you find in this figure 4 here on page 23. Okay, so here is line A. So what you're going to do with a trusty utensil, in my case my favorite Algonquin College pencil, I'm actually going to plot the liquid limit and the plasticity index on this table. Okay, so my liquid limit, I'm going to remind myself, and for your benefit, for this example was 54. The PI was 26. So I find 54. Here is 50, here is 60, so 52, 54. Right there. And the PI of 26. So I go up this line, 20, 30, so 22, 24, 26. So 26 is right here. So I go across the 26 until I find 54. So I'm basically here. So this is actually above the A line. Again, this is actually above the A line. So what I do now is I go back to this table, which is figure 3, page 22 of your textbook, and I go in this column here, because I've determined that it's already somewhere here. Atterberg limit below the A line. No, we saw that it was above the A line. Atterberg limit above the A line. Oh yeah, this is a possibility. Again, we know this is true, this is true. So that's a possibility. What about here? Atterberg limit below the A line. No. So in this case, this sample that I've posted for you to try out is this. CH, in organic clays of high plasticity, also called fat clays. Okay, symbol CH. You can also find this symbol right here. So that's how you do your analysis. The last thing you have to do then for the purposes of this lab is write up the report. So you basically identify what the sample was that you got, or pardon me, that you identified through your liquid limit and plastic limit. And that shows you another way to identify fine soil by using a method that is not the sieve analysis. Now don't forget, the gold standard for identifying fine soil is not the Atterberg limits, it's instead the hydrometer test. But we're not going to do that. However, I've linked for you the hydrometer test on Blackboard. Thank you for your time.